Today we're going to learn to solve, identify, and write systems of two linear equations. Below you will see some facts that you need to know in order to move ahead with systems of linear equations. Remember, your equations will be written in slope-intercept form, y equals mx plus b, where m is your slope or rate, and b is your y-intercept, also known as your initial or starting point. Your equation may also be written in standard form, ax plus by equals c. The most important thing is to remember you have two variables and you have an equation, and both variables are set as two or more equations. Also remember, a system can have two or more lines, and linear equations must make a straight line. As I stated before, a system of linear equations is two or more linear equations with the same two variables that are solved simultaneously. The solution of a system of linear equations is any ordered pair. Remember to write your ordered pair as x comma y. There's a solution of every equation in the system. What does the solution represent? The solution represents the point of intersection of the graphs of the lines defined by the equations. For example, here I have two lines. That point where the two lines intersect, that is your solution. Here on top we have 5 sets of equations or statements. Some of them form systems and some do not. Remember what a system is. It is two or more equations with two variables that are the same and that we can solve at the same time. This first pair is a system. Now, I know the first equation does not have an x, but remember, equations can be simplified. If it has no x, that means there are 0 x's, which means the equation is really y equals 0x plus 10. Which is simplified down to y equals 10, since anything plus 0 gives you itself. This second statement, 2x plus 3y, is not a system. 1, that is not an equation. Equations must have equal signs. 2 is not two or more equations. This pair is a system. Again, the first equation is written in standard form. The second equation is written in slope-intercept form. 2x plus 2y equals 4 is not a system because it's only one set of equations. It needs to be two or more. And this last one is a system. Now do this one on your own. Give you a few seconds to decide what the answer is before I circle them. Which of the following represents a system of linear equations? If you said items 2 and 3 are systems, you are correct. Now we're going to see how it is we can find if a certain point is a solution of a system. Basically, all we're going to do is plug in the point into our system, and if it makes each equation true, then it is a solution of our system. For example, we have the point here 2, 4. 2 is our x coordinate, 4 is our y coordinate. So wherever we see x and y, we're going to plug that in. So our first system says y equals 2x and y equals 6x minus 8. When we plug in our y and x into the first equation, we get 4 equals 2 times 2. Well, since 2 times 2 is 4, that makes this statement true. Our second equation is y equals 6x minus 8. So when we plug it in, we get 4 equals 6 times 2 minus 8. 6 times 2 is 12, minus 8 is 4. 4 equals 4. Therefore, this statement is also true. Since both statements are true, that means 2, 4 is a solution for this system. Now, let's look at the system for B. Again, we're going to use the same point, 2, 4. So when we plug in our x and y, we get 2 minus 4 equals negative 1. That is false. Now, we could stop here because once we hit a false statement, then that means the point is not a solution. But just in case, we do the second one. Again, we plug in our x and y. 2 times 2 minus 4 equals 1. That is false. 2 times 2 is 4, minus 4 is 0. Since both statements are false, that means 2, 4 is not a solution to the system. Now remember, in order for it to be a solution, both equations must be true. If any of the equations in the system is false, the point is not a solution to the system. So 2, 4 is a solution to the first system, but not the second system. Here's one for you to do on your own. Is 3, negative 4 a solution of the system? And the system is 3x plus y equals 5 and x minus y equals 7. Give you a few moments to solve this one on your own. All right, remember the first step is to plug in your x and your y. When we plug in our x and y for this first equation, we get 3 times 3 plus a negative 4. 3 times 3 is 9 plus a negative 4 is 5. 5 equals 5. So this first equation is true. Now we move on to our second equation. So we have 3 minus a negative 4. 3 minus a negative 4 becomes 3 plus 4. 3 plus 4 is 7, so 7 equals 7. Therefore, the second equation is also true at that point. Since both equations turned out to be true, that means 3 negative 4 is a solution of the system. Let's take a look at some word problems. Wildlife biologists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown in the table. Write a system of equations that biologists could use to compare the weights of the alligators. If you look at the table, alligator 1 initially weighed 4 pounds, and its rate of growth is 1.5 pounds per month. Alligator 2 initial weight is 6 pounds, with a rate of growth of 1 pound per month. Remember, the most common form of the equation is y equals mx plus b, where m equals your slope or your rate, and b is your y-intercept or your initial starting point. We're going to call the first alligator Allie 1. Since Allie's rate of growth is 1.5 pounds per month, we will say y equals 1.5x. Her initial weight was 4 pounds, so we're going to say plus 4. The second alligator we're going to call Gator 2. Again, its rate of growth is 1. So we have y equals 1x. And since its initial weight is 6, we put plus 6. Now, we can simplify this equation because we don't write 1 whenever it's multiplying a variable. So we will change this to y equals x plus 6. So our system is y equals 1.5x plus 4 and y equals x plus 6. Again, here's another word problem. I will read it out loud and give you a few moments to write your system. Marine biologists studied the lengths of 2 species of shark for several years. The initial length and growth rate of each species are shown in the table. Write a system of equations a biologist could use to compare the lengths of the two species. We have Greenland shark and a spiny dogfish shark. All right, the Greenland shark. Its initial length is 37 and its rate of growth is 0.75 centimeters per year. So our equation will be y equals 0.75x plus 37. With the spiny dogfish, its rate of growth was 1.5 centimeters per year, and its starting point was 22 centimeters. So its equation is y equals 1.5x plus 22. That means the system is y equals 0.75x plus 37 and y equals 1.5x plus 22.